Welcome, welcome, welcome to Unit 3, Lesson 5, the cosine function. I don't know about you, but we just came back from February break. I feel so refreshed. In fact, not only did we just come back from February break, but we got that Monday off due to that windstorm of 75 miles per hour, which was awesome. I have to admit, I was not ready to come back to school Monday, but having Monday off, having that extra day, Tuesday, man, I am revved and ready to go. This is awesome. Glad to be back. You would think after a week off I'd be okay coming back, but I'm not. I wasn't. Now I am. All right, so let's take a look at the cosine function. If you remember last lesson, I think we just finished the sine function, and now we're moving to cosine. This should look familiar. This is the unit circle, and just like we did for lesson 4 with sine, I'm going to put coordinates on the quadrantal or the 90-degree increment angles, meaning, remember, this is 0 degrees, this is 90 degrees, 180 degrees, 270, and then we come back 360, one complete full circle. And I'm going to put coordinates here, all right, at each point of our 90-degree angles. Now, I'm going to put the coordinate. Remember, the unit circle has a radius of 1. Okay? That is a radius of 1. So every one of these coordinates would have a 0 and a 1 in them somewhere. Meaning, this first coordinate right here is 1 on the x, 0 on the y. This coordinate up top is 0 on the x, 1 on the y. To the left, negative 1 on the x, 0 on the y. Of course, I mean, I'm speaking of the coordinates. And at the bottom here, it's 0 on the x, negative 1 on the y. Now, if you recall, my y value represented my sine, okay? Which means my x value will always be the cosine of that angle. So what's the cosine of 0? It's this x value here. That's the cosine of 0 or 360 degrees. It's 1. Okay. What's the cosine of 90? It's the x value. The cosine of 90 is 0. What's the cosine of 180? It's the x value, negative 1. And what is the cosine of 270? It's the x value, which is 0. Okay. So we're going to take this information that we know, we're going to kind of just put it on a table below here. Let's put it on a table. The cosine of 0, of course, is 1. The cosine of 90 is 0. So I'm going to go ahead with this here. The cosine of 180 is negative 1. The cosine of 270 is 0. And then the cosine of 360, it's the same as the cosine of 0. And that's 1. Okay, right there. So 1. So now we've taken it from our unit circle, okay, and we've put it on this nice table, which we have here, which is great. Now from this table, we're actually going to draw a graph of cosine. Okay, let me do this so we can see the degrees and our cosine value at those degrees. All right, so right now our x is our degrees. Okay, so x, those are our degrees in theta. All right, and our y is actually the value of the cosine of whatever the degree theta is. So we can start out at 0 degrees, and I'm going to go all the way out here to 360. Half of 360, that's 180. Half of 180 is 90. If I add 90 to 180, I get my 3/4 value of 270. All right? Now, cosine, just like sine, will go up to 1. That's as high as I go. That's the highest value, y value. And the lowest y value would be negative 1. And then, of course, it'll be 0 at certain times. All right? So let's plot these coordinates. 0, 1. 0, 1. That's where I start, cosine. Okay? Then at 90 degrees, I'm at a value of 0. So at 90, that's an actual 0 on my graph. It's an x-intercept. Okay? At 180, I go to negative 1. That's down here. At 270 degrees, I have another 0, or another x-intercept. And at 360, I go back up to 1. And again, this is not straight. What I'm about to do in yellow, do not do. This is not just straight, okay? That would be an absolute value curve. It looks like a V, okay? That is not it. This is called the sine or the cosine curve. Trigonometry, you always hear the graph referred to as the curve, okay? Because it curves. It's curvy by nature, all right? So when I do this, I'm going to want to kind of curve, boom, then change, down, kind of do curve back up, then change, okay? There it is. That's cosine. Now, to me, what I tell my students is sine looks like the S, okay, on its side. Cosine looks like a cup. C for cup for cosine. S for sine looks like an S, all right? Here's cosine, looks like a cup. Well done. And now you understand where that comes from. And by where it comes from, if you're like, no, I don't, it's the unit circle, okay? It's the values of cosine at these angles. We took it from the unit circle here, made a table of it, and then just plotted that table. And we come up with our cosine curve. Now, this isn't something that you got to memorize. It's just something neat to observe. And there's something that I always like to tie into it from science and DNA and just the human beings, the race, just what we're made up of, our composition, which ultimately comes from space, stars. And so this math can kind of relate to everything that makes the universe up, which is crazy. I know I'm going too far. But what's the relationship between sine and cosine, okay? Well, if I have a graph here, and I go from 0, I go 90, 180, 270, and 360, all right? And I'm going to plot, oh, excuse me, I got to my y. I go up to 1, down to -1, and here's 0. Let's start with sine, which I will do in red. Okay, sine starts at 0, ends at 0, the middle 0. It goes up, then it comes down, okay? So kind of looks like this, this. That's a good sine curve, okay? In red, that's the sine of x. Let's do blue for cosine. Cosine's a cup, all right? It starts up high, and it ends up high. Okay, in the middle, it's down low, low, low. And then in between those points, hey, Elizabeth Vanette, I got to close that email out. Okay, in the middle, in between my high and low points, that's where these zeros are, and then it kind of curves like this. Boom, very good. Now, what's the relationship between those two? That would be the cosine of x. Really, they are just a 90-degree shift away from each other. What does that mean? If I take sine and I move it 90 degrees to the left, boom, it pretty much lays right on top of cosine, okay? Yep, let me move that back. If I take cosine and move it 90 degrees to the right, that pretty much lays right on top of sine. So they're really just a 90-degree shift left and right away from each other. But you're like, Visca, you mentioned something about space and human makeup or whatever. See, what I see when I see sine and cosine, if I take and I connect my sine curve and cosine curve with a bunch of vertical lines, meaning I take the distance between the curves and just connect them. Like the distance between cosine and sine, boom, boom, and I just draw a series of vertical lines between them. To me, do you know what that looks like? Let me see if I can get rid of the... Yeah, cut. Look what happens. That worked out so beautifully. Watch what happens here. And this is just, cool stuff. I'm going to group it so when I do it like that, that's a DNA coil. That's exactly what our DNA looks like. That makes up the characteristics of us. So whether we have blue or green eyes or, hazel eyes. I happen to have green. I love them. And whether we have dark hair or blonde hair or you're a ginger for all you Doctor Who fans. That's people with red hair. All right? Or you shave your head like Mr. Visca does because you know what? I'm cool. I'm wearing a bow tie today, too. Lovely, lovely visuals that you can't see through this video. But it just makes up everything, how tall we are, how short we are, whether we're male, female, whatever. It's all made up, and it can be represented by a sine and cosine curve. And to me, as a mathematician or a math teacher, that's fascinating because I love space and math, and I love that they're tied in like that. Okay, let's get out of the cool fantasy-like stuff that makes math really cool, and let's do some boring graphing stuff, okay? Remember, just like when we graphed sine, we have some other values that might be with our cosine of x. We have A, that should be our amplitude, right? We have B, that's our frequency. We might have this value D, which could be our midline, okay? And then I can find out the period by taking 360 and dividing it by the frequency. Or, if it's in radians, we can take 2 pi, because that represents 360 degrees, and divide it by the frequency. All right, so remembering this, let's move forward and let's graph one cycle of y equals 2 cosine of 3x. Now, again, what I like to do is I like to figure out all my information first. Amplitude frequency, midline, this is like saying plus 0. So my midline, I'm adding nothing to it. So my midline is still going to be 0. So my amplitude, 2. My frequency, 3. So my period, that's the length of one cycle, okay? Remember, frequency is how many cycles I should see in 360 degrees. That's what frequency is. So in 360 degrees, or to graph this, I would see 3 cosine cups, or 3 cosine curves. The period tells me the length of one cycle or curve. Why do I want to know that? Because they want us to graph one cycle, so I need to know where it ends. So I take 360, I divide it by 3, and I get 120 degrees. That is the length of one cycle. Okay. My midline is still y equals 0. That's still the x-axis. That is not going to move up or down at all. Okay? Now, let's graph this bad boy. So we go, I start at 0 and I end at 120. That's why that's important. What's half of 120? Well, I think it's 60. What's half of 60? Well, I know it's 30. 30 and 60, that gives me my 3/4 of 90. And my amplitude is 2. So I know I'm going to go up to 2, and I'm going to go down to -2. And my midline is still at 0. Okay? My midline is still at 0. Right. So, cosine curve starts up high, and it ends at 120 degrees up high. In the middle, at 60, it's down low. And in between my highs and lows, that's where my x-intercepts or zeros happen. That's where the midline is. So, and I just draw a nice little curve, nice little curvy dude. Boom, there you go. You just graphed 2 cosine of 3x. Badoosh. On to the next one. Graph one cycle of y equals -3 cosine of x. Coffee, so good. Now, graph one cycle. My amplitude is -3. My frequency, that is technically a 1 right there. It's a 1x. So my frequency is 1, which means my period is 360 divided by 1, which is 360. I'm adding nothing to the outside, so my midline is still y equals 0, or the x-axis. Okay, let's graph this. Oh, but wait. This is negative. That means there is a vertical flip. Because, so instead of opening up like this, it's going to vertically flip. It is going to open down, like a downward opening parabola. Okay, except it's not going to go down forever. The ends kind of tail and flatten off. Okay, so please note, we are flipping. Why? Because there's a negative sign. Our function is negative. So let's start by drawing the axis. Okay, I know it goes to 360 degrees. From 0, half of that, it's 180. This is our standard graph. 90. In between here is 270. I know the midline is 0. And from 0, my amplitude, I put it's -3. It's 3. It's +3. The negative just means it's flipping. Okay, so my amplitude is 3, which means from my midline, I'm going to go up 3 and down to -3. Okay, so this is where I'm graphing. All right. Now, instead of starting up and then ending up, okay, I'm flipping this. Okay, I'm starting down and I'm ending down. And my middle, instead of going low, is where I'm going to go really high. In between those points is still my midline, which happens to be my x-intercepts. And I open it. Bam, just like that. That is great. It's a perfect graph. 100% credit. Should be. I mean, I'm the teacher. I'm teaching this. I should know it. But now you know it too. There's a second question here, a follow-up to example 2. What is the domain and range of this cycle? That's important. Because if they don't tell us to stop after one cycle, technically, cosine will just keep on going on forever and ever and ever. So when I ask for domain, which is my x values, and range is my x value will just keep on going on forever, and will go on forever. But they just want the domain and range of this cycle, which means it has endpoints. It stops here on the x-axis, and it begins here. So my domain, okay, my domain is going to be from 0 to 360 degrees inclusive, which means I have filled in holes there, or filled in dots. There's no empty holes. I want to include 0 and 360 in my domain. My range, that's the ups and downs. It goes as high as +3 and goes as low as -3. So it goes from -3 to 3 inclusive, which means it does include those values. It's not just less than 3 and more than. It is less than or equal to or more than equal to. It includes those values. So again, my domain is the x value. That's how far left and right I go. Okay, and it goes from 0 to 360. My range are my y values. That's how high and low I go. I go from -3 low to +3 high. Just a little follow-up question. And now you know. Okay, example 3. They ask us kind of the same question, but throw a little twist to it. Graph y equals 2 cosine of 2 theta from 0 to 2 pi. All right, greatness here, greatness here. So what we've got to do is the same exact thing we've always done. We're going to start by doing the amplitude, frequency, so forth. Amplitude is 2. Frequency is 2. The midline, there's nothing that I'm adding or subtracting, so my midline is going to be 0. So my amplitude is 2. My frequency is 2. My period is, now they give me from 0 to 2 pi, so instead of 360, I'm actually going to use 2 pi. I'm going to use radians. So I take 2 pi and divide it by the frequency, which is 2. That means my period, or my length of one cycle, the 2's would cancel. It's pi or 180 degrees. Okay? It's pi or 180 degrees. Now, my midline, that's still at y equals 0. There's no up or down movement. Okay? And this is not a vertical flip. So I always tell my students, and sometimes I do this, sometimes I don't. I know that this is going to be a cosine cup because now we have 2 curves to pick from. We know sine, it's an S. We have cosine, it's a cup. So I like to even just sketch, okay, what am I graphing? Just a reminder, oh, it's cosine, so it's the cup. It's not flipped. It's going to look like that. Okay, I'm going to have a graph that looks like that. Now, they don't want me to graph one cycle. They want me to graph from 0 to 360 degrees or 2 pi. Frequency tells me how many cycles I should see in 360 or 2 pi. So when I'm done with my graph, I should see 2 cosine curves that look like this, back to back, okay? And that should go from 0 to 2 pi. Let's do this. Zero. This is 360, which is 2 pi. Half of that is 180, which is 1 pi. Half of that is 90, which is pi over 2. And then 270 is 3 pi over 2. All right? Now my midline, still at 0. And my amplitude is 2, which means I'm going up from the midline 2 and down 2 from my midline. All right? Well, let's graph one. Let's graph one cycle first. Okay? It should end at pi. So it starts up high and it ends. One cycle ends at pi up high. In between these two dots is pi over 2 down low. Okay? And exactly in between the ups and downs here, probably right here and right here, is where I'm going to touch my midline. And I'm going to go like this. All right? Now, some people might want you to label where these intersect, okay? And there's two easy ways to do this. Well, one is easier for you guys than the other. Isn't this really, I'll do this in blue. This is really 360 degrees. So this is 360, which makes this 180, which makes this 90 degrees. Half of 90 is 45. And then if I add 45 and 90, I get 135. Okay? And all my tick marks are going to be in 45 degrees away from each other. So there's going to be another one here, another one here. So this will be 225. This right here is 270. And then I add, what did I say, 45 to that. It'll be 315 here. Okay? So that's in degrees. All right? I should actually write these in blue, 225 and 315. Right? So that's in blue. Now, if they tell you, they don't tell you you need to label in radians, so that would be fine. But I know that half of 90 is 45, that's pi over 4. Okay? Then, think about this. If this is 1 pi over 4, okay, this is pi over 2. That's the same thing as 2 pi over 4. That means this is 1 pi, 2 pi. This one is 3 pi over 4. Pi is the same thing as 4 pi over 4. And I could just keep on going. 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Okay, look it. We just increase our pi by 1, and they all stay over 4. 1 pi over 4, 2 pi. So we can kind of just go down there. Now, if that confuses you, convert it to degrees. That's fine. Okay, there's nowhere that says that there's nowhere in this problem that says you have to label your axis using radians. They give you radians. That's all fine and dandy, but it doesn't say you have to label it in radians. I just did both. Okay, so now we're technically only halfway done with our problem. We have graphed one cycle. Okay, you see this right here. They don't want one cycle. They want it graphed from 0 to 360. So if each curve is 180 degrees in length, right? My first one went from 0 to 180. My next curve, I need to go from 180 degrees here and go out another 180 degrees to 360 because that's the length of one curve. So what I do is I pick up right where I left off, and my cosine, it starts up high and it ends 180 degrees away up high. In between these 2 points, that's where I'm down low. And in between my ups and lows at 225 or 5 pi over 4. And at 315, which is 7 pi over 4, that's where it's going to cross the midline. Of course, these little dotted things aren't going to be there. And now we have another curve. And doesn't it make sense that we see 2 curves in 360 degrees? It should, because our frequency is 2. That tells us how many curves we're going to see in 360 degrees. We see 1, boom, and then we see 2 in 360 degrees. That's exactly what our frequency tells us. And what's the length of each curve? 180 degrees. 180 degrees. How do I know that? That's what the period tells me. That's the same as that's the length of one curve. So each one curve is 180 degrees. So doesn't it make sense that if I graph two of them, I have 180 plus 180, that two of them are going to be in 360? That's why these two are connected. Okay? Sorry I got excited and fast there for a moment. But, you know, that's the beauty of it. It's all connected. It all works out. Okay? Oh, boy. Oh, boy. Oh, boy. All right. Graph the function f of x equals -3 cosine of theta over 2 from 0 to 2 pi. Again, just like last time, they don't want one cycle. They want from 0, and for comfort's sake, that's like saying 360. Okay? From 0 to 360. All right? So the first thing I'm going to do is, this kind of looks intimidating the way it is right here. This looks intimidating. We got a fraction, a negative, and the whole. I'm just going to rewrite it, okay? So I'm going to say f of x equals the negation of 3 cosine. That's like saying 1/2 theta, okay? Now, to me, it's less intimidating. My amplitude is 3. That's my amplitude. My frequency is 1/2. My period is 360 divided by 1/2. I will reach for this computer and smack you if you tell me that's 180. It is not. If I divide 360 by 2, it's 180. But if I divide it by 1/2, I'm not dividing it into 1/2. I'm dividing it by 1/2. That's 720 degrees. Now, one cycle is 720 degrees. We're not even going out 720 degrees. We are going out to 360. Okay, so we're not even going to see one full cycle of our cosine curve when we're done. Okay, let's just establish that fact right now. So when you're graphing this, you shouldn't be like, how come I don't see the whole cup? Because one whole cup is 720. We are only going to 360. We're going half that distance. So guess what? We're only going to see half that cup. Because in 360 degrees, I should see half the curve. Again, that's what my frequency tells me. How many curves in 360 degrees? Well, we're graphing the 360, so I should see 1/2 of my cosine curve. All right? My midline is still y equals 0. I'm not adding or subtracting anything. I'm not moving up or down. Oh, but don't forget, negative sign out front. There is a vertical flip, which means not only will it look like this, but I'm only going to see half my, when everything's all said and done, I'm really only going to see half my cosine curve. It's really going to look like that when I'm all said and done. But you know what? For the sake of ease, let's graph it to 720. And then I'm going to show you how we only need to see half of it, okay? So that will help you better grasp and understand this, okay? Here we go. Let's graph it to at least 720. So 0 all the way out to 720. Half of that is 360. Half of 360 is 180. If I add 180 and 360, I get 540. Okay, my midline is 0. My amplitude is 3, which means I go up from my midline 3 and down 3 from my midline. And I am drawing a cosine curve that is vertically flipped. So instead of starting up high, my cup is going to be tipped upside down. I will start down low, which means I will end at 720 down low. And in the middle, right at 360, is where I go up high. In between those 2 points, at 180 and 540, I touch my midline, which is my x-axis. And I graph this bad boy. That's a fantastic graph. I'm proud of you. But we only want this from 0 to 360 degrees. All right? We only want this from 0 to 360. So I only want from 0 to 360. So technically, this part that I'm highlighting here, we don't even want in the problem. So we're just going to wipe that right off. I'm literally about to erase that, okay? If you want to, you can cross that out or whatever the case is. But I want you to see that we only needed to graph half of this. Because if I'd graphed half of this without the whole cycle, some people get confused, like, wait, I thought it was a cup and whatever. They want from 0 to 360, so I'm going to give them from 0 to 360. There you go. Didn't I say earlier we're going to get rid of half this? And it should look something like that. And look what we got. That's perfect. That is perfect. Oh, yeah. Yeah, they always do this. By they, I mean, I guess me, because I decided to leave this in here. But it's good. It's good. It's healthy. It's good. Builds math fluency. Numeracy. Let's just do the problem. Anyways, let's graph one cycle. Okay, whew, good. We're done with that 0 to 360 BS. We're just graphing one cycle of y equals 5 cosine of pi over 3x minus 3. There's a whole lot of whooping going on here. First of all, the midline is no longer going to be where y equals 0. It's no longer the x-axis. Okay, we have a value, a new value for a new midline. We're going to run with it. Okay, and I noticed that there's not just a number in front of my x, my 2x, meaning I have an amplitude of 5, but my frequency, you better darn well note, is in radians. So when I figure out the period, I should take 2 pi and divide it by my frequency. I shouldn't take 360. I can still label the x-axis. Don't worry, we're going to get there. Don't freak out. Oh my God, I have to label it in radians? Watch the magic that's about to unfold. Okay, my amplitude, well, first of all, my midline becomes -3. But my amplitude is 5. Simple. My frequency, we're just copying what it is. It's pi over 3. My period is 2 pi, or 360, divided by whatever the frequency is. This is divided by pi over 3. Now, the simple algebra that you still need to be good at is, whenever I divide by a fraction, I got to multiply by its reciprocal. Let's go back a problem here. When I took 3, and I was like, man, I will slap you through the computer. I cannot take 360. I don't just divide it by a half and say, oh, it's 180. No, dividing it into halves would make them 180. But when I divide by a fraction, I need to multiply by the reciprocal, 2 over 1, to get rid of it. So I need to multiply the top by 2 over 1. 2 over 1 is the same thing as 2, isn't it? 360 times 2 is 720. Okay, that's how this works. So you should have said that when we did the problem, Visca. Well, you should have known it. This is algebra 2. Aha. Gaha. Just try the soup. You've never seen Coming to America? Nah, never mind. Anyways, let's do this. Now we've got this problem right here. I'm going to multiply by 3 over pi. The reciprocal. The 3's cancel, and so do the pi's. So now what I do to the bottom, I have to do to the top. So let me write this. I've got 2 pi times 3 over pi. Oh, the beautiful thing that happens here. My pi's cancel. 2 times 3 is 6. And that is my period. That is the length of one cycle. So my y-axis doesn't have to go out to 6 pi over 7. Anything right? It's just my y-axis is going to go out to 6. All right? My midline. That's at y equals -3. Or I could just say -3. But I'd like you guys to know that it's kind of like that imaginary horizontal line, y equals -3. And it's -3 on the y-axis. Okay? So, we haven't had any movements left and right yet, and that's fine. Let's even forget that I even mentioned that. But let's go. Let's graph this. Oh, and last but not least, it is cosine, and it's not negated, so it's gonna look like this now. Okay, it's not the S for sine. We're still dealing with just cosine. So let's graph this bad boy. So I'm going to do this by the blue, by the B, and I'm going to put my x-axis not right in between. I'm going to put it a little bit higher. And why do I do that? Because I'm going to start this way first. My midline is at -3, which means I need to go my amplitude up 5 and down 5, not from 0, but from -3. So if I go up 5, I go -2, -1, 0, 1, 2. I go up 5 to positive 2. Then if I go down 5, negative 4, negative 5, negative 6, negative 7, negative 8. Okay, so I'm actually going from my midline up 5 to 2 and down 5 to negative 8. All right. Now, my x-axis, I start at 0 degrees and I go, well, radians, degrees, whatever, to 6, because that's the length of one period. It's fine. It's good. It's good. It's good. It's good. Half of 6 is 3. Half of 3 is, in case you didn't know, 1.5. And if I add 1.5 and 3, I get 4.5. Fine and dandy. Well, that's my marker. Nothing wrong with that, okay? There's decimals. The pies were there. They're gone. Visca, I'm freaking out. Don't worry. Everything's all good. So let's start to graph this thing. We know it's positive. It opens up. It's the cosine curve. The cosine curve starts up high. So it starts at 0 degrees or radians, whatever. Goes up high, and it ends at 6 up high. In the middle, on our x-axis at 3, it goes down low to its minimum of negative 8. And in between my highs and lows, at 1.5 and at 4.5 on your x-axis, it will hit the midline, which is now negative 3. Okay? And all I'm going to do is draw that little cup. Do the same thing. And this one is not so little because I kind of drew this graph big, but that's cool. It gives you a better idea what it looks like. It's fantastic. It's fantastic. You are super. You're a great person, and you just graphed. Man, I'm so proud of this graph. I'm gonna label this dang thing. That is 5 cosine of pi over 3x minus 3. Holy cow, we are good. Look at that. That was all complicated, and we tackled it like beasts. We're crazy. We math strong. I'm gonna get a T-shirt. Math strong. Bam. Wear it every Friday. Boom. Sorry, I got carried away. Anyways, let's move on. Writing equations of the cosine functions. Okay. Example 1. Sketch one cycle of a cosine curve with an amplitude of 2 and a period of pi over 2. Then write the equation of this curve. All right. Well, let's start by just sketching it. All right. It doesn't say anything about the midline, so I'm going to assume it's still at 0. And amplitude is 2, which means it goes up 2 and down to negative 2. Starts at 0. And where does it end? This is where it ends. That is pi over 2, which is the same thing as 90. If you want to make it 90, go right ahead. Okay. Half of 90, 45. Half of 45 is 22.5. If I add 22.5 and 45, I get 67.5. All right. This is a cosine curve. It doesn't say whether it's positive or negative. It just says graph a cosine curve. I'm going to leave it positive. Why would I ever want to make things negative if it's my choice? I'd love to keep things positive every time I can. Even my cash flow. Now, I start up high. I end up high. In the middle at 45, down low, low. And in between those, at 22.5 and 67.5, are my midline points. In this case, my zeros, or x-intercepts. All fine and dandy. Good. That's really all I need to graph this. But they want the equation. The equation should be written y equals my amplitude, cosine frequency, x. Yes, I know this is a b, but I like to use a and f. You know me. All right? Now, that's easy for my amplitude. My amplitude is 2. They give that to me. Cosine, they don't give me the frequency. They give me the period. Remember, period equals 360 or 2 pi divided by the frequency, but p and f are interchangeable. I can say f equals 360 divided by the period. And that's exactly what I'm going to do here to find this f. They give me the period. Now, since there's a pi in my period, instead of 360, I'm going to use 2 pi and divide it by pi over 2. Okay? Don't forget, if we're dividing by a fraction, we need to multiply by its reciprocal. 2 over pi. Pi's cancel, 2's cancel. What I do to the bottom I have to do to the top. So I have 2 pi times 2 over pi. That's like over 1. The pi's cancel. What's 2 times 2? That's my frequency. That is your equation right there. Boom! You're good. You are good. You're good. No, you are. Stop saying you aren't. You are. Smart. Okay, we're going to do these last 2 and then stop here. Okay, find the period for each of the cosine curves below. Write an equation for each function given the interval is from 0 to 2 pi. Okay, so what they're telling me here is this is 2 pi or 360. Okay, if I want to know the frequency, or write the equation, rather, I need the frequency. I need to have a cosine of f, which is the frequency, or I could say b times x, all right? They also want to know what the period is, okay? I'm going to do this for both of these. A cosine frequency of x, all right? So how do I find the period? The period is 360 divided by the frequency. So let's first find the frequency. How many cosine curves do I see in 360 degrees? That is by definition what the frequency is. I see 1 curve. I see, oh my God, I see 2 full curves. So my frequency is 2. So 360 divided by 2, that's 180. That's the length of 1 curve. And that should make sense. The halfway point is 1 curve, right? That's 180 degrees. So my frequency is 2. Okay, my frequency is 2. So cosine of 2x. What's my amplitude? 1, 2, 3, 4, 5. The midline's here, -5. So my amplitude is 5. That's my equation. My period, we just figured out it's 180 degrees. Or if you want to call it, you could say it's pi over 2. It's the same thing. Let's move on to the next one. Okay? My frequency. Well, if this is 360 degrees, or 2 pi, I only see half of my curve. If it continued, it would look like that. That's a full curve. I don't have that. I have half, which means my frequency is 1/2. Okay, my amplitude, 1, 2, 3, it goes to -3 to +3. So my amplitude for my midline goes up and down 3. But wait, this cosine curve, if I continued it, it's flipped. A cup looks like this. This one is flipped. I got to make sure I negate that. That's my equation right there. All right? And last but not least, they want the period. They want the period. Period is 360 divided by my frequency, which is 1/2. My God, don't say it's 180. 720 degrees. If I want, I can put that in radians. Well, 2 pi is 360. And if I double that, 720, that's 4 pi. Not too bad. I mean, I went through those kind of quickly, but these are all based on things that we're learning and we should have known and kind of gone from there. We use the same kind of ideas and structure that we use for graphing and coming up with equations for sine that we do for cosine. All right, we're going to stop here, and we have some other problems to work on. Yeah, application problems. Those are fun. We get to draw pictures. I will see you for part 2 very soon. Have a good one.